The first part, I will discuss with you about propositional entailment. Propositional entailment. To have brief concept about these sessions, we are going to see the example. Example 3. Everybody knows if the earth were without water, then there would be no life on earth. I will give you another example. If you don't study hard in high school, then you will find it difficult to get into a good university. This is what book says about propositional entailment, and this is our conclusion. The book says the statement is propositions in the form if P then Q. In this example, P is a proposition. The earth were without water. Proposition P here. And Q is the propositions. There would be no life on earth. The proposition P. You see the form if P then Q. If P then Q. The proposition if P then Q is called propositional entailment, denoted by P infer Q. The proposition P infer Q can express by saying P entail Q, or from P we infer Q, right? So we can transform this example. The earth were without water entails there would be no life on earth, or from the earth were without water we infer there would be no life on earth. I'm going to give more example about this session for you, and after that you make sums for you. Okay, if it's rain, then the street will be wet. This is the propositional entailment with the form if P then Q, or another example. If you do exercise every day, then you will be healthy. So you see, in the form if P then Q, or you can use this form and P entail Q. It's rain entail the streets will be wet, or you do exercise every day entail you will be healthy. Okay, and this is exercise for you. Proposition P. The northeast monsoon is plowing, and proposition Q. It gets cold, and the request of this exercise stay the proposition P infer Q. It's so easy. And you two form. First, the northeast monsoon is plowing entails it gets cold, or from the northeast monsoon is plowing we infer it gets cold. This is the relations between proposition P and Q. So paying attention to it. The proposition P infer Q or entails Q is false only when P is true and Q is false. Thus, we determine whether P entails Q is true or false only when P is true. Then, if Q is true, then P entails Q is true. And if Q is false, P for Q is false. It's called complicated and more difficult to understand. So just pay more attention. The first condition to determine a propositional entailment is true or false is propositions P had to be true. After that, we examine proposition P Q later. So this is our example. Okay, when you analyze the example, it's difficult for us to understand more. The example 4, the propositions -3, okay, is less than -2. So infer I use this infer THEO. Okay. The -3 square is less than the -2 square. So we determine whether these propositions is true or false. First, we see is follow the form P infer Q or P entail Q. This is P's propositions and the Q's propositions. Q. You see, -3 is less than -2 is true. Okay, but when we square both sides of its inequalities, we have the proposition Q, but you see -3 square equal 9 because it's less than -2 square equal to 4. But this is a 4 proposition, so QE is false. 4. So the whole this propositions is 4 because P is true but Q is false, so this proposition is false. Another example, square root of 3 is less than 2 is a true propositions because you know square root of 3 is equal to 1.4. In entail, we square both sides of this inequality. We have 3 is less than 4. Okay, PE is true and QE is true too. So the whole propositions is true. More knowledge on these sessions. Math theorems are true propositions and usually have the form P entail Q. Then we say P is a hypothesis and Q is a conclusion. Or to put it another way, P is sufficient for Q, or Q is sufficient for P. And that is our knowledge about this topic. Next part is exercise for you, and I help you to solve this exercise. Given triangle ABC from the propositions P, triangle ABC has two angles equal to 60, and proposition Q, ABC is an equilateral triangle. What is equilateral triangle? In geometry, an equilateral triangle is a triangle in which all three sides are equal and all three internal angles are also equal to each other and are equal 60. Okay, I will give you a triangle, equilateral triangle. First side, okay, the second side, and third side. So if, for example, if the first side is equal to 3 centimeters, second side also equal to 3 centimeters, and the third side is also equal to centimeter. Okay, equilateral, and the internal angle, that's internal angle. So I use another color, internal angle, right? Okay. Internal angle. 3 internal angle are equal 60 degree, 60 degree, 60 degree. So this is an equilateral triangle, and the request of the exercise: state the theorem P entails Q, state the hypothesis and conclusion, and state this proposition again using the sufficient conditions and necessary conditions. First, state the theorem P entails Q. Okay, P entails Q, or from P we infer Q. Triangle ABC had two angles equal 60. Entail ABC is an equilateral triangle. Triangle ABC had two angles equal to 60 is sufficient for ABC is an equilateral triangle, or ABC is an equilateral triangle is necessary for triangle ABC had two angles equal to 60 degrees.